Rate of a reaction. Rate of reaction is a concept which we come across in the chapter Chemical Kinetics. Chemical kinetics is the branch of chemistry which actually deals with the study of rates. That is nothing but the fastness of a chemical reaction and the factor affecting the mechanism by which the reaction proceeds. All these concepts we study under the chapter Chemical Kinetics. So, chemical kinetics is nothing but the description of the rate of a chemical reaction, or we could say the rate at which the reactants are transformed into products. All this concept we study under the chemical kinetics. So, if we say what is rate of reaction, it is nothing but the rate at which the concentration of the reactant or product participating in a chemical reaction alters is called as the rate of reaction. So, the speed, the fastness at which the concentration of the reactant or product changes, we call that as a rate of reaction. If we try to represent the rate of reaction in the form of a formula, we say that it is change in concentration divided by time. So, the unit will become as moles per liter divided by your time. If, for example, we take a chemical reaction where we say A plus B is equal to, or A plus B gives C as the product, then the rate of the reaction will be equal to minus del A by del T, or minus del B by del T, or plus del C by del T. So here, if we are talking about the rate of reaction of the product, that should be positive, and the rate of reaction of the reactant, then it would be negative. So now let us see what are all the factors which will affect the rate of the reaction. Surface area of a solid reactant can affect the rate of a reaction. So, the rate of the reaction will increase if there is an increase in the surface area of the solid reactant. Second, the concentration or pressure of a reactant can also affect the rate of the reaction. That is, the rate of reaction will increase as the concentration of the reactant increases. Third, we could say the temperature also plays an important role in the rate of reaction. The rate of reaction will increase if we are increasing the temperature. Next, the nature of the reactant also plays a vital role. That is, the nature of bonding in the reactant will actually determine the rate of a reaction. Basically, if the reactant has ionic bond, the rate of reaction will be faster. And the most important, catalyst, presence or absence of a catalyst, because we all know a catalyst is a substance which will increase the rate of reaction without actually participating in the reaction. Hence, these are all the factors which will affect the rate of the reaction. Next term comes what is average rate of a reaction. Average rate is always equals, or we could say average rate equals change in measurable quantity divided by change in time. So, average rate of reaction will be equal to change in concentration divided by the time. Hence, the average rate of reaction is said to be positive when the rate of concentration of the product is increasing. But the average rate of reaction will be negative when the rate of concentration of the reactant decreases. And next term comes, that is instantaneous rate of reaction. The instantaneous rate of reaction is nothing but the rate of a reaction at any particular point in time. That is a period of time that is so short that the concentration of the reactant and the product will change by a negligible amount. And that point in time, we call that as an instantaneous rate. Or in short, we could say the initial rate is the instantaneous rate of reaction, because as it is going to start. So an instantaneous rate is a rate at some instant in time. So if we say for a reaction, reactant forms the product or reactant gives the product. So your rate of the reaction will become as negative for your reactant and positive for the product. So del of your R by del T, or del of your product by del T. So we are having the instantaneous rate of the reaction as d of R by dt or d of P by dt. And the sample problem related to rate of the reaction. For example, we could see this problem for the reaction R, which is giving the product, that is P. The concentration of the reactant will change from 0.03 m to 0.02 m in 25 minutes. We have to calculate the average rate of reaction using units of time, both in minutes and second. So if we say, in order to solve this problem or in order to solve any numerical, the first habit we should have is note down the given value. Here it is given as from 0.03 m to 0.02 m. That means our R2 is going to become as 0.02 and R1 is 0.03, and the change in concentration takes place in 25 minutes. That means T2 minus T1 will be equal to 25 minutes. So we all know it is del R by del T. Thus we could substitute the value and get the answer as 6.67 into 10 to the power of minus 6 m per second, and that could be converted into per minute, as they have asked us the average rate of reaction both in minutes and second. So similarly, we could practice many problems from rate of the reaction, because it's a very important topic from the chapter Chemical Kinetics. We get so many numericals from this chapter, hence it is very important to practice.